A very warm welcome to one all present here. Good evening to our audience and good morning to Dr. Ravi. Before we begin this webinar, I would like to share some few guidelines that we would like to maintain to the audience. The first is that the audience needs to keep their audio on mute and the videos turned off so that there is no network issue that can happen during the webinar. And second is that all the questions that you have during the webinar, you can post it in the chat and we will pick up those questions. I and Kriti will be the moderators and we'll pick up the questions and make sure they're answered. We'll try our level best to answer all the questions. With that being said, let's have an introduction of a guest speaker. Dr. Ravi N. Margasahayam. So Dr. Ravi did his Bachelor's in Mechanical Engineering from RVCE in 1975. He did his Master's in Aerospace Engineering. Then he went on to do his MBA in Corporate Finance Strategic Marketing, and finally, a doctorate in General Business Management. After finishing his education, he, for the next decade, he worked at Boeing under various industries which spanned helicopters, commercial airplanes, military aircrafts, and also involved solving complex problems, technical problems related to tribology, helicopter gears, bear design. After that, he went on to his greatest adventure, NASA. In 1989, he began as a Vibroacoustic researcher, went on to become Chief Launchpad Systems Engineer and Safety Systems Engineer on the Space Shuttle program, and finally became the co-chair of the Ground Safety Review Panel. Ground Safety Review Panel has been responsible for multiple launches of aircrafts to space, inclusive of Moon. Dr. Ravi is responsible for launching various low Earth satellites, which also involves the Hubble Space Telescope. Then he is involved in 100+ space shuttle missions and launching 700 astronauts in space, including the first Indian female astronaut, Kalpana Chawla. Dr. Ravi is NASA's international expert and lead scientist on rocket launch-induced and vibration technology, and he is the only person of Indian origin to work on the launch pads 39A and 39B simultaneously. His journey, after 28 years of his stellar career in NASA, he retired in 2016, and then later on in 2019, he became the Solar System Ambassador for NASA Jet Propulsion Laboratories. Dr. Ravi has many research and award under his name. There are some few that we have listed here. In 1996, he was awarded the Silver Snoopy Award for his exceptional engineering and innovation space shuttle. He has authored, presented 50+ reviewed technical papers nationally, internationally. And in 2002, he himself organized and co-chaired the 9th International Congress on Sound and Vibrations. And in his most recent adventure, he has written a chapter in Infinite Worlds, that is a book which is based on last Hubble Space Telescope mission. With this being said, I would like to welcome Dr. Ravi to the webinar. Very warm welcome, Dr. Ravi.
Thank you, Abhishek. Really, I'm just an ordinary person in an extraordinary place, and I'm with you guys. It's a really honor and privilege to be here with all of you today. Most importantly, I want to take a minute because if it's a Ganesh Chaturthi and Puja, so I just want to pray Lord Ganesha to start the presentation here today. And then I want to dedicate this presentation to my mother who passed away 15 years ago, and then my father who just passed away 2 weeks ago, 15 days ago. So I just want to dedicate them. Because of them, I'm here today. Because of my mother, actually, I went to RV college and my dad paid for it. So just want to give them the credit for what I am today. With that, I really want to, I like your motto here, go change the world. I would want to change that to go change the universe. So with that, let's go ahead and start the question answer. So I'm just seeing the screen shot here, I guess, right? That's about it.
Yeah. So,
okay.
Now let us, since a speaker introduction is necessary, so we thought we'll just introduce Team Antariksh as well. a small presentation that we want to hold.
Okay.
Oh yeah, I'll ask my co-moderator Kriti to take over from here.
Okay, great.
Hello everyone. So speaking about Team Antariksh is a student space technology team at RV College of Engineering. The team was formed in the year 2015 with a vision of inspiring young minds to take up challenging tasks in space technology through interdisciplinary research as well as development. So we are a team of 100 plus members from all over different branches and year. We in Antariksh follow a research-oriented work culture, and we are also one of the few student teams in India with both rocket and satellite projects. Speaking of the project, our first project is RVCE, a nano-satellite project. Our aim is to perform a microbiology blow experiment under microgravity condition in low Earth orbit. We are also designing a cost-effective payload with impeccable quality and conforming to highest standards. And the payload is also first of its kind in all of India. The payload is designed to be placed in ISRO's PSLV stage 4. So this is about RVSat-1. Moving on to our second project. Our second project is Resolve-1, which is the acronym of Recoverable Suborbital Launch Vehicle 1. So it's a sounding rocket project that we have undertaken, which will perform electromechanical experiment. And we are also participating in Spaceport America Cup 2021 at New Mexico, which is a competition for sounding rockets. And again, we are proud to tell that we are one of the 4 teams from India to be selected into this competition. And we are planning for an MOG of 10,000 feet with the help of our sound rocket. The image that we can see on the screen is our team student members and our faculty advisor, Dr. Ravi N, who is the HOD of Aerospace Department. So moving on to the next slide, we can see different images. The first image wherein our team members, along with Dr. K. Sivan, they had attended Human Spaceflight Conference at ISRO Bangalore. And the second image is of our team members who participated in IAC 2019 Washington, D.C., the conference. And then the third picture is any regular day at our space lab, our working place in RV College of Engineering. So moving on to the next slide. We are also proud to announce that the team has had about 30 publications across various conferences across the entire world. And happy fact is that we are from our team, 14 abstracts have been selected for the IAC 2021 conference this year, and 7 abstracts for IEEE 2021 Aeroconf conference. So this is a small gist of our team. Over to you, Abhishek.
Yeah, thanks, Kriti. So let us begin with Journey from RVCE to NASA by Dr. Ravi. Dr. Ravi, can you tell us how was RVCE back in 1970s?
Yeah, it's last time I visited RV College of Engineering in I think 2017. I just really didn't even know where it was and stuff like that. But going back like the 1970s, it was a very remote site. I remember we were just a third semester batch. We had the IC scheme there. We had a small cafeteria outside the center and inside the center, I guess. Very few buildings, very pristine, very remote, hard to get, I guess. Transportation was an issue. But I think it was a very conducive environment to learn. And money was tight. We used to drink like 6x10 coffees or whatever. There was no phones, no social media, so no distractions, I would say. As far as studies goes, I didn't even have a calculator or a slide rule. I used to do log tables and still beat everybody else. So no books, minimal books. We used to use teachers' notes, and we just got together and made our own notes basically and stuff like that. So, but one of the things that reminds me is that we always wanted to be the best. We were not considered the best at that time. So unfortunately or fortunately, which really drove us to excellence in trying to work towards beating, say, BMS and UVCE. So we'll talk a little bit about it later. But it was a very interesting think that how I came to RVCE, I just want to brush upon that. Being born in Mumbai, I went to Burma. I was living in Burma for many years. I was looking at some Caterpillar trucks and tractors there with my dad, working for United Nations. Then we moved to Kabul, Afghanistan. My dad worked for United Nations and also American Embassy. But more importantly, I think after coming back from Kabul, I saw a movie called Sangam, and that was the real trigger for me to, I guess you guys were not even born those days, And the trigger was, if I became a pilot, I would marry a beautiful girl and go around the world. So with that trigger was really what turned the entire journey into what I am today, basically. It never happened that I became a pilot because my mom said, if you fly, you die. My dad said, no money. So anyway, my dream was alive. And right around 1969, I had a massive failure in 1970 as NASA was landing man on moon. And 1970, we had the Apollo 13. I had my own Apollo 13 moment there, which really caused me to fail in my exams, which really led me to RV College of Engineering. So it's an interesting story.
That is amazing. Sir, do you remember any professors of the college right till now, or you are in contact with them?
Well, I used to be in contact with Suresh Kumar. He's one of the professors who taught us, I think, strength of materials. I vaguely remember. I was in contact with Chennaiya, one of our department chairs, and we had a lot of fun, I guess, with the professors. Luckily, I grew up in Mumbai, but I learned Kannada. So when I came to Bangalore, they thought, although I was from Mumbai, because I speak and write Kannada, they thought I'm a Kannadiga. So they all took me under the wing, which was really nice of them. And really, they trusted us, and we looked up to them, and they trusted us. So we did many, many things with them as if they were our own classmates and colleagues and stuff like that. So really, that made us a big family, and it was really nice that some of the things they instilled in us, like without the books and without a lot of equipment and tools and things like that we see now in modern day universities and stuff like that, it is very, very hard for one to teach. And luckily, they went beyond their call of duty, in my opinion. And I think just to give my hats off to them, I want to mention one thing. I've been to 60 countries around the world, and I always think about RV College gave me a foundation like the pyramids of Giza. Before Giza, there were many failures like the bent pyramid or the step pyramid and all that. So all those failures were necessary for us, to have that foundation. And the base of the pyramid, I call it is my RV College days, the 5 years which made me what I am today. So really, a lot of times in your life, what happens is you journey and never know your destination, but you have to journey. Nobody else will journey for you. You have a dream, you continue with your dream. You have to find your own paths and stuff like that. And in the end, what happens is you may get a very great surprise like me. I never thought I would become a NASA engineer, but just happened to be in the right place at the right time and grab hold of opportunities.
That is amazing, sir. Sir, are you still in contact with your batchmates from 1975 batch? And
yeah.
Are you aware of what they're doing?
Right. We have a RV College 1975 group in WhatsApp, and I just joined about a year or two ago, and they've been really feeding me a lot of information. Some of our close friends have passed away, but there are many other friends who we get together whenever I'm in Bangalore. And we had a good meeting with them and reminisce the past. And I think because I was from Bombay, they all took me under the wing. And many times I can tell you some anecdotes where I was really sick or I didn't have good hot food. People would call me home and feed me and take care of me as if I'm their own son or daughter, basically. It's like very, very nice, harmonious relationship between us and the students of RV College. And even today, I literally, shed my tears sometimes, about how affectionate they were, how compassionate they were. And even our professors, they would come and sit with us, and many times they would talk about, the good, bad, and the ugly. Really, it's amazing. We had that camaraderie.
It's really amazing to hear that even after so many years, you're in instant contact with them. Uh, in 2015, RVCE started the aerospace department to equip people with the knowledge and skills required within aerospace industry. And we have been led under the able leadership of Dr. R.S. Kulkarni, sir. And I just wanted to know that how do you feel about this endeavor taken up by our college?
I think it's a great idea because I wish when I was growing up and studying in RV college, we had a group like that. Really, groups like this really bring the best minds together. Why NASA is the best name in the world today is because of collective thinking, collaborative problem-solving capability. So if there's a problem like Apollo 13, we put 1 million people around the world to work. This is the beauty about having something like a club where people can associate, and like my center director Bob Cabana always said that from small beginnings come great things. So I'm expecting great things from you guys. As you know, we have been already, we have climbed Mount Everest. When I was born in 1953, I met Tenzing Norgay in 1973 on an RV college mission to North India. And he sort of commented that you cannot wander around the bazaars of Darjeeling to end up on Mount Everest. So now your challenge is, I think me and, I broke the space ceiling maybe in Kennedy Space Center, NASA, achieving the highest award there and stuff like that. But I think for you, you have to climb Olympus Mons on Mars. So that's what I want you to do. So, quoting Martin Luther King, he says, if you can't fly, then run. If you can't run, you walk. If you can't walk, you crawl. But by all means, keep on moving. So when there is movement, and you will come up with many ideas and many goals and objectives. So I hope RV College supports you. But there is a lot of requirement that we need to have interaction with the industry.
Really amazing, sir. In the follow-up question, I would like to ask that what field of aerospace engineering that have you seen grow in the most in your years of experience, research-wise and industry-wise?
I think research and industry, research is a requirement that, the industry poses, because even NASA, the entity itself, we cannot do many things, So even if you look at the Apollo program or the Space Shuttle program or the ISS program, we always had the universities work with us very closely. We wanted the partners from many universities, not only in America, but around the world, come together. So in my opinion, that research and, what the industry does in terms of actual hands-on work, there are 3 to 5 million parts in Apollo and the Space Shuttle. It's impossible for NASA alone to be doing the work. So we have to partner with the industry, basically. And that helps us to create more ideas and quick problem solving. As you saw on Apollo 13, we called it a spectacular, successful failure, basically. It was a spectacular disaster in the happening, basically. But we turned it around, That is, I've used this quote, basically, these 3 men were beyond the physical reach of humankind, but they were not beyond the reach of human intelligence, imagination, and ingenuity. So Gene Kranz that day stood in front of all the NASA engineers, all the corporations, and all the engineers worked for entities, researchers worked for NASA. Even some of the people from Toronto, 5 professors were programming to get these astronauts back to Earth. Okay, that was a major disaster. It would be a very black mark on NASA's name. But working together around the world, we had 3 days to get them back. it was an amazing challenge. So just want to impress upon you, these three men were beyond the physical reach of humankind. If you fall in a pool, I can give you a hand, but not at 200,000 miles away. So these three men were beyond the physical reach, but not beyond the human intelligence, imagination, and ingenuity. And by the by, we just sent a rover called Perseverance rover to Mars, Ingenuity helicopter. I came from a helicopter background. Leonardo da Vinci, who's my hero, he came 500 years ago, he was flying helicopters. So we have a lot of connection with Ingenuity. I'm looking forward to seeing that happen. And JPL, NASA Jet Propulsion Laboratory, who I'm part of also, did the helicopter. So you know how NASA uses industry very effectively along with the researchers.
Oh, that's really amazing to hear, sir. So moving on, I would like to ask about your journey after RVC.
Well, it's as I said, we talked a little bit about the journey, from my childhood days to RV College. And after RV College exam, I just had to. I was thinking of taking TOEFL by chance. I took TOEFL. I never took GRE. I didn't have any plans. I was missing my family, so I went to Middle East. That's where my father was working for. In Muscat, Sultanate of Oman. I went there without any plans. Then he used to build showrooms for Mercedes-Benz, so I started liking Mercedes-Benz really. So one of the plans was me to work for Mercedes-Benz. But then my friend who is no more now, he's my RV College colleague, he said, why don't we go to America and see America also in the process? And that made us go to America for 6 weeks. And when I went to Germany, they refused to consider my RV College degree. They said, you have to study again. I said, no way I want to do that. And my aunt in Chicago said, the 5 years you spend in Germany doing your engineering again, you do a master's and PhD in America. So please come to America. So that's what happened. So if you imagine, the world will collude with you to make it happen. So I went to America as a tourist, almost no money, no admission, on December 4th, 1975. And by January 13th, I was already in IIT Chicago. So I never went to IIT in India, but I went to IIT Chicago. So that's how I ended up in IIT and studied aerospace engineering. And I think rest is sort of, fell in place because I think, as I said earlier, it's important that there's a nice quote by JPL. Scientists study the world as it's, but engineers create the world which never was. So when I failed in Mumbai, my mom said, be an engineer, just like my dad, who was a civil engineer. So my passion was that if I can fly, just like Leonardo da Vinci, I said, why can't I make the flight of others possible? So that's what I said. I'll become an engineer, maybe an aerospace engineer, so I can work in Boeing and other companies or aerospace companies, so I can make the flight of others possible. So in life, sometimes, you can have a plan A, but if it doesn't work, you have an adaptive plan B. So people ask me, Dr. Ravi, what happens after plan A, plan B, up to Z? I said, you find a new language, you have more characters there, so keep on adding more and more options because, possibilities thinking is very important. In the old days, RV College days, Chennai would come and say, Ravi, tell me a question. He'll ask a question and ask me an answer. So one question, one answer. In NASA, we think possibilities. One question, many possibilities. And each one of those possibilities becomes a innovation in the end. So innovation is very important. Personal innovation is very important. So that's where I came to Chicago and started looking at options. And that put me to become an aerospace engineer.
That's really impressive, sir. So you completed your BE from India and then moved on to US for your master's. So did you feel a significant difference in the way of teaching between US and India? How did you basically adjust to the environment there?
I didn't. I think I got a C in the first semester. And we didn't, the Indian English is totally different from American English. And we had a class of like 300 people. It's very hard to listen to the professor sitting way back. And in RV college, I used to sit in the front desk, I guess, or so close to the professors. So really, the way of teaching is different. They rely more on your own studies. They don't give you notes like India did. We had a lot of books in the library, but it was very hard to go through all the books to be ready for the next class. And I think these quizzes, they give you not a big essay question like India. They were more requiring you to study and answer like yes or no type questions. So in some ways it was good, but what was good and what I missed in India was, missed that India should have is the experimental knowledge, So why I'm the best engineer today for NASA was because I feel and touched in every single part of the shuttle. When I went to NASA, there were 100,000 acronyms. I had to learn everything. I had to find out what mobile launcher pad MLP is or what VAB is. I had to go and touch physically. And that's important, that there's a difference between American education. They rely too much on you, a lot on you to study, but also they give you practical experience, industrial experience and stuff like that. So, that was, I think, the major difference between what I studied in India, and the teachers were same. I think the foundation was great in India. Where math and science, the STEM subjects were very good in India. When I came to America, I think I got the hands-on knowledge, and that is very important for me because, we can keep on talking about rockets all day, all night. When you go physically right next to Apollo Saturn V or space shuttle on the launch pad, which I've gone hundreds and hundreds of thousands of times in my 28-year career, you touch and feel that rocket, you feel something enormous. You feel that energy, you feel part of it. And that's what I missed in India, and I hope India can change with that.
That's really nice to know, sir. So could you share your experience with your first job and regarding how it helped you set up your future career?
First job in America, right? Yeah.
Yes.
You won't believe that, my boss in Boeing one time always told me, Ravi, you have to crawl before you walk, before you run, before you fly, because he came from Boeing. And my first job was railroad engineering. Can you imagine that? So, once you're a railroader in America, you're branded no technology, so basically, but luck favors the prepared mind, as well as luck favors when your mind is open to a lot of ideas. So at IIT Chicago, although I studied in aerospace engineering, there was no money for research there. So the only money my professor had was in railroad research, and I did tribology research, friction, wear, and lubrication on railroad wheel and rail interaction, which is a phenomenal thing because not many people understood how the wheel rail wear and lubrication happens. This is the fundamental of any subject. Even your eyelids, when they're bad, there is friction, wear, and lubrication, basically. So that is a universal truth. And we were trying to understand how it happens. And really, as a kid coming from India, not knowing much about America, I was at the mercy of all these people. But luckily, I chose to do, as they say, beggars cannot be choosers. I said, I'll do the research. And that led me to work in a railroad company called Conrail. And that was, again, a fluke. In America, I went from a tourist to becoming a student visa holder. And then from there, I got a job in Conrail. But Conrail required a green card. And I didn't have a green card. In those days, they would say, you need a green card to get a job, or you need a job to get a green card. So which came first, the chicken or the egg, So they assumed that I was from Philadelphia. Chicago. I was born in Chicago. They hired 15 white people, white Americans, and I was the only colored American, colored Indian, They didn't even know I was an Indian at that time. They thought I was born in Chicago. So when they asked for my papers is when they found out that I don't have any papers and I shouldn't be working legally. Luckily, my boss was such a nice guy, and he happened to help me to get my green card. So basically, sometimes, I believe in what Dr. Kalam says. You have to fail in some areas, and that failure will lead you to the destined path to your destiny, basically. So don't think that failure is a step backwards. Failure is an option. It was only not an option on Apollo 13, but now I feel that failure is an option. So I moved on to Boeing. Conrail, and within a year or two, one of my friends, he was working for Conrail. He got an opportunity to go to Colorado for a Boeing interview, and he went there for an interview. And by the time I had my green card with Conrail, so see how it happens. When you imagine something, the world will collude with you to make it happen. So he rejected the job, but he said, if you want to go to interview, you go to Boeing in Colorado. So I took the job. I took the bait and said, okay, let me go for the interview, and I'll get a free trip to Colorado anyway, even if I don't take the job, because I had a job on Conrail already. And I was working on the railroads there. And this was the railroad research job. And I met my boss, former boss, who is no more, Harry. And, he was so impressed. I was the only engineer in America at that time, I think, who had a aerospace engineering degree, but had done research in railroads, And Boeing needed somebody like that. So that's how I joined Boeing. And I got my job right in February, March, and I told him, I said, Harry, I know you want me right away, but I want to go to India and get married. So can you hold the job for 7 months? And he looked at me quizzically. He said, why the hell you need 7 months to get married? In America, we can get married in 7 seconds, 7 minutes. Anyway, Boeing held my job for 7 months, and I came to India, got married in 1981. So just wanted to tell a small story there. So that's how I came to a railroad job, and then worked in Boeing for 10 years in railroads, mining, helicopters, commercial airplanes, and NASA in 89. So that's how my progression was. We talked a little bit about building the pyramid here, crawling before you walk, before you run, before you fly. So railroads, I thought that, as a aerospace engineer, I hated railroads and no technology. I wanted to work in space technology. But we'll talk a little bit about that when I come to NASA's areas here. And I'll tell you why that railroad experience was very important to me.
That's really nice to hear, sir. Indeed, your experiences are, a factor of motivation to all of us. So, you explained about your first job, and how did you finally land up in NASA?
That was again a fluke, So really, again, it's important that you keep on working towards your destiny. I said, even if you fail, you try to continue your journey. And as I said, my first job with Boeing was in Colorado. I got married in 81, 82. My wife came, and then, we lost the contract in Boeing contract for railroad research. So we moved to Pittsburgh, Pennsylvania. And at that time, I got a job in Boeing. They asked me to work in mining testing. So I know it's interesting that, mining was again not my option, but I learned so much about research, and activities in railroads, writing papers, measurements and stuff like that. We were working on a $100 million facility in Colorado. Now I am working on a $50 million facility in Pittsburgh, Pennsylvania, working on mining testing. Imagine if you are all engineers, imagine you have a cube of 20 feet sides, almost 6-7 meters sides. I can apply vertical compression of almost 3 million pounds and horizontal shear of about a million pounds, biaxial shear. So imagine a cube of 6 meters, I can put it there and apply this load. That was the biggest compression testing facility in the world, And I learned so much about hydraulics and fluids and electrical systems and electronic systems and testing and instrumentation. Again, it was not my goal. My wife moved to Philadelphia later on for her job. So I wanted to move to Philadelphia, and I kept on telling my boss, Harry, who had hired me in Colorado, to move me to Philadelphia. And then it took him quite a bit. So I had to take some pay cut and go to Philadelphia to be there for a few months. And then finally I ended up getting a job in helicopters. So the people in Boeing helicopters, they said, you worked in Boeing, but your job is in railroads and mining. We can't take you. You don't have aerospace experience, although you may have a degree. And that's when Harry, my boss, really went to bat for me. And then in 89, I worked for 84 to 83 to 86, 89, I worked for Boeing helicopters, designing tilt rotor helicopters, the V-22 Osprey, the Comanche, the all composite model 360 composite helicopters. We built gearboxes, and bearings and all composite bearings. Very, very interesting work. One day I went to the library to do some research, and the lady in the library wouldn't let me go inside. She says, you have a red line on your badge. I said, what do you mean by that? I said, you're not a citizen. I can't let you in the library. And I was like upset, and I came back and told my boss, Raymond Drago. Raymond Drago was a small, short Italian guy. He was a genius, clear designer. He's the world's leading expert. So he said, this is not fair that we are doing research for Boeing and they are not letting me in the library. So he calls the president and said, hey, we need to get him a admission to the library or get him a citizenship. And that sort of helped me to get a citizenship. So without that citizenship, I couldn't have ended up in NASA in Florida. So now in 89, my wife finished all her training in Philadelphia and she wanted to move to Florida. And that's when I said to myself, I don't want to be alone again. So we wanted to move to Florida. And I applied for a few places. And basically, we had a small office in Boeing in NASA in Florida. But they said, because you don't have a rocket background, we cannot take you. And the only rocket background I had was Challenger disaster in 1986. When I was working on Boeing helicopters, we heard about Challenger disaster at liftoff. So Boeing used to own Rocketdyne, and Rocketdyne is the one company which built planes, Boeing 707 type planes, which became the space shuttle. So I was sort of, we knew about it, we are part of Boeing. So we felt very sad, not because we are associated with it. We were removed from it, but we are also associated in a way. So when I came to Boeing, when I saw the Challenger accident, I said, look, I wish I could work for NASA. Until then, my only trip to NASA was in 1976, right after joining IIT. I just went to Florida just to see the museums. That's about it. So really, it was an eye-opener at that time. But then one thing led to another thing, and that ended up me getting a job at Kennedy Space Center.
That's indeed very impressive. So my next question would be, like, working at NASA, can you share some advice for an aspiring space organization, especially regarding how you view things from a systems perspective?
Yeah, I think that's one thing. I was yesterday I was talking to Abhishek about many things. We'll talk a little bit about that. But one of the four things you want to write down maybe is, you have to think, believe in yourself, dream, and dare. These are the four I can call mantras or whatever. This comes directly from Wernher von Braun, who is the father of a V2 rocket in Germany, but also he was the father of Apollo Saturn V rocket. So it's very important to dream, think like, have a trigger like me or something else on what you want to do. Believe in yourself in what you do. Dream about it, but dare, basically. So one of the things we teach in NASA is that when we have a problem, we always look at the root cause analysis. We also understand the systems or engineering of systems. We have a knowledge of multidisciplinary abilities. And last but not least, presentation or talking to people about how this failure happened, basically telling a story, basically. So my journey in NASA and why NASA is great today is because they are systems engineering expertise. Can you imagine working in an environment when you have 6 million to 3 million parts? Everything has to work together, and you're launching a rocket. You just get the first chance to launch a rocket. There's no testing involved. So systems engineering and integration and testing is one of the foremost things which NASA was the best in, and they instilled that same thing in our minds also. So when I went to NASA, I started working on the launch pad systems, as you know, vibroacoustics, but I also involved in many aspects of the rocket as a systems engineer. So you took the space shuttle, the orbiter, the white plane-like looking thing, connected to the 2 solid rocket boosters and the orange tank. All these have to be integrated, basically. So these are extremely tough jobs. And when you integrate all this, you have to put it on a mobile launcher platform, which itself weighs about 9 million pounds or almost 4.5 million kilos. And now you put it on a crawler transporter, which weighs itself 3 million kilos. So the whole stack weighs about 9 million kilos. How do you move 9 million kilos from your office in the VAB to the launch pad, which is almost 3 miles away? It's an amazing feat of engineering, which NASA engineers designed and did, basically. So to understand all these aspects, even at the later stage, we remember we talked a little bit about railroad engineering, which I did before. A lot of systems on the launch pad were moving on a railroad. So whatever I did in Conrail and Boeing before came in handy. I worked in Boeing helicopters working on gears and bearings. So even up to maybe 2/3 of the space shuttle program, we didn't understand that there is something called the rollout fatigue. We have a very high cycle fatigue, which comes from basically moving almost 8 hours to the launch pad. So when you have like a 0.01 hertz or 0.01 hertz coming from a roller bearing, from a crawler, which moves on the ground, and it goes through the mobile launcher, and it goes through the shuttle, it can vibrate the shuttle, and it can create fatigue cracks. Nobody understood this. That is called the rollout fatigue. We are putting millions of cycles of loading. So it is very interesting phenomena that we take everything for granted in systems engineering. For a spacecraft, the payload itself is usually comprised of instruments, sensors, something like Hubble Space Telescope, right? For the launch vehicle, the payload itself is the spacecraft, basically. But what is more important is NASA was very good in defining the payload requirements. We call it the ICD, the interface control documents. These are one of the most important things, how each one is connected. So each part, these 3 million parts were individually tested as well as tested together. Good example would be Apollo 13, Apollo rocket itself. Wernher von Braun was so adamant that he wanted to know the natural frequency of the whole Apollo rocket, because he knew that once I put on the launch pad, there's the last time I will see dynamic testing of a rocket. You can't test it physically. I cannot generate 190 decibels of sound, 100 Gs, and simulate that 5,000 degrees temperature, the thermal vacuum environment, and the G-load environment and the acoustic load environment anywhere in the world, because all those combined loads could not be produced until you go for a launch. And that is what was important for us to not only define the interface control documents, but also test what you fly what you test. So not only the individual components were tested and done, but once you install them together, we tested them again, So you may ask me, how do you test a shuttle? So what we did was, after 5 launches of the space shuttle orbiter, we would bring in and put about 300 sensors on the orbiter and apply loads, static loads, basically, sort of a little bit dynamic loads, quasi-static loads, to understand the natural frequency changes in the system, basically. So that is a very interesting subject for you to understand systems engineering. So in a summary, define your requirements for ICD requirements, interface control documents, build and test all those individual parts, test, fly what you test what you fly is the name of the game. So I understand you're flying something on PSLV or whatever, that's the mantra. And coming from me, you have to take it for really with a big deal, because imagine Hubble Space Telescope being inside the space shuttle payload compartment and 190 decibels coming and hitting it. Well, it doesn't, it's not 190, maybe less than 990. It can damage the Hubble. So even before you launch, the payload goes bad. So that becomes a big challenge for you. So you have to be really, really worried about that. So.
Ravi, Sinu here from Bangalore. You can tell about the acoustic noise and how do you measure it?
Okay, well, acoustic noise, we going back, I think NASA is the only place where we had more than hundreds of launch measurements, and that's why we were the leaders in vibroacoustics and launch pad. Can you imagine a rocket with almost 7 million pounds of thrust, or 3.5 million kilos? You have to react it to the ground. So we have to build very big infrastructure, heavy infrastructure to take up that load, basically. And we had almost 3,000 sensors on the launch pad, both acoustics as well as vibration sensors. Because for me, the job was to understand how the launch acoustics come up and how it becomes a load on the structure, basically. So we call it the vibroacoustic coupling, basically. So, one good example would be the last Hubble mission, repair mission, STS-124. I lost 3,000 bricks on the main flame deflector, which is right below the solid rocket nozzle. So this deflector, the purpose of it is to take the big impact from the plumes of the solid rocket booster and turn it 90 degrees. So we put all the acoustic energy far, far away from the rocket. But there is still many more rocket energy there. So we put 300,000 gallons of water. But then once the rocket takes off from the pad, even it takes off like less than a foot or a meter, the water doesn't make sense because you see all the water turning into water vapor. So basically the acoustics goes everywhere. It goes into the payload, it hurts the structure of the rocket, the payload, the launch pad structures, something can fall off from the launch pad. So we put even sensors right under the rocket, and that's where we measured the acoustic loads, and then converted that acoustic loads into many doing FFTs and other things, came up with cross correlation and pressure correlation distances, and many things to understand how this acoustics becomes a load on a structure and launch pad. So I was one of the engineers who also put my own structure on the launch pad, which was amazing that NASA never lets you put their own structure. So what we did was we put a cantilever beam, which we know by design what the natural frequencies are and what the 3 or 4 modes are. And I instrumented them with acoustic sensors and also put accelerometers. And we measured the acoustics and then put that load in a finite element analysis. And that provided the response, basically. And the response was equivalent to what the accelerometers told us. So that's how we validated. And that's how...
Srinivasan Margasahayam here. Hi, Ravi. Yeah, that helped refurbishing the launch pads. So your photo is there on the wall of fame in NASA. You can just tell about that also.
Okay. So basically, I was working on that STS-124 mission, and in NASA we have a rule: if you see something, say something. And because we had Columbia accident in 2003, I was very particular as a NASA safety engineer and a systems engineer not to have a problem. So when this 3,000 bricks started flying, I went against NASA management and shut the launch off. And a lot of NASA managers were very upset at me. And that really put me a lot of stress. And I ended up going to the hospital. I had health issues already, and so I went with a quadruple bypass. So really, NASA, by shutting the launch, they were very upset at me, but eventually they put the sensors. And one of my friends who was there taking pictures of the Hubble took my picture, and apparently that ended up in the book called Infinite Worlds. And then we built the $100 million museum for Space Shuttle Atlantis. They asked Michael Soluri, who wrote the book, to send some pictures. And so right under Atlantis rocket, my picture is, and it was there for the last 5 years, and they had taken it out. Now they're putting it back again. But incidentally, right opposite to where my picture is. That's where Columbia Challenger Memorial is. So it's kind of very, very sad feeling when you start walking in the museum. You're looking at the big success with Atlantis, 33 launches, 100 million plus miles in space, many, many revolutions and stuff like that. Then you see Columbia Challenger Memorial. And so basically, it's nice to be part of a legacy where, if I want to live one legacy, that would be the one that you do something profound to influence. So even when you see something wrong and your colleague or somebody does a mistake in your interface documents or inspection or testing, you point it out, because otherwise, when you put it on PSLV rocket, if it fails, it's a bad thing for you. I'll tell you why. Because you'll be working for a Perseverance rover or an Ingenuity helicopter. You'll be putting in 30 years of your life, even just to go to Mars. And can you imagine something like, it fails on Mars, crash lands on Mars? Okay, that's a bad day for you. You may never get a second chance. I think we did quite a bit of job on the systems engineering. So the mantra again is the 4 things I told you. Root cause analysis. So root cause analysis is the most important thing. We have 2 things there. One is called the proximate cause and the root cause. So what is proximate cause? So Columbia and Challenger, the proximate cause was for Columbia, it was the O-ring, the foam hitting the leading edge of the rocket. Just a few pound foam, 1 pound foam hitting it, which caused the small pinhole, which created a problem during landing. So out of 100 launches I lost 1 in my lifetime. Not during launching, but at landing. Challenger was the O-ring problem. So that's the proximate cause. But what is the root cause? So root cause is always, proximate cause is always technical, but the root cause is always human in nature. So the root cause was in Columbia. We knew the foam shedding, but NASA managers went against it and said, we have a 6 sigma problem. We'll bring it very close to the mean. We'll bring it below 3 sigma and say that's not a problem. So we did a normalization of deviance, they call it, if you want to read about it. Same thing in Challenger. We had a O-ring problem. We were not supposed to launch. We had the strict launch criteria, commit criteria, making sure that we don't launch during cold weather, and there were cracks on the O-ring. So that is the most important thing in your life. Even if you fail in your life, look at the proximate and the root cause analysis. Second thing, understand the engineering systems, how each system comes together. And when you look at the problem, it will define. When we started putting Columbia together, it's a very sad thing. One day, it's a beautiful, beautiful bird, $2 billion, rocket, which comes back with 200,000 pieces, which we can collect, and it's spread around, on a pad, in a hangar in NASA. It's a very sad thing. So we put every single part together trying to figure out where it failed. And one of my best friends, Pamela Melroy, she was in charge of the investigation. So understanding how systems work together is very, very critical. Third thing, multidisciplinary. It comes from Leonardo da Vinci, who was not only a painter, but also designed many, many war machines for rich people in Milan and some other places. But also he was cutting bodies under the church's nose, right inside the church. So basically there's a mix of many, many things there. So one time somebody asked him, I said, if there is no war, what do I need? Why do I need your war machines? He said, okay, if there's no war, I can paint. One of these times I can paint. And one of his paintings went for $400 million. So in my case, it would be something like understanding railroads, looking at instrumentation, maybe understanding gears and bearings and how they affect machine design. All came in handy when I moved to NASA. So I became more aware of things, and I could use my knowledge and apply that. And in the end, you have to make a presentation. One good example would be somebody like, Gene Kranz would come out and say, look, we have to be tough and competent, So you have to instill passion in these people that they want to be the best in the world, In the end, it's your name. I want all of you, 100 people listening now, your name is the most important thing. It has to be a gold standard in the world, the best in the world. So those 4 things I want to go along with your other 4 things we talked about. Think, believe in yourself, dream and dare. And now root cause, systems engineering, multidisciplinary knowledge and storytelling. So document everything. If not for you, for the future generation. Okay, let's move on.
I would like to welcome Dr. Srinivas for the webinar. We are very proud to have you on this webinar also.
Thank you.
Dr. Ravi, you have worked in NASA for a long time, and you have had many landmark events like the Kalpana Chawla launch. So can you just share some moments that you had during the first launch when you launched Kalpana Chawla in space?
I think we can write a book or a big document on that, really. When you, I think I told you earlier that my journey was one of a serendipity. There is a very good book I want all of you to read. Other than Infinite Worlds, we talked a little bit about failures. If you want to understand failures, read a book by Henry Petrosky. And there's a book called Plan B by David Murray. I can send you all this information. But there's also a book by Alchemist. It's called Alchemist by Paulo Coelho. He's a great author from Brazil. So it's a story about a small young boy who's he has a dream that he sees a treasure in the dream, and he follows his path or journey all the way to the pyramids of Giza, trying to dig in a hole. And then he meets some thieves who really come after him, and they say, why are you digging here in the middle of nowhere in this desert? And he says, look, I'm looking for a treasure. And the guy laughs at him, and the thieves also try to dig there, but nothing there. One of the thieves tells him, look, you're really stupid, because I had a dream just like that a few days ago or weeks ago, that there is a place in where you come from, and there's a tree and a church, and right under that tree is the treasure. And apparently, this boy realizes that he came all the way to Giza to find something, but now he can find it right under the tree, where he's born. So my journey was something similar to that, except because I was just looking to maybe participate in becoming a aerospace engineer and pilot. That dream happened about a few years ago. One of my best friends from Denmark, he took me on the Kattegat Peninsula in the northern part of Denmark to fly, and I was holding the stick. So it just happened about 40, 50 years later. So, but NASA was a different thing. So when you become a part of NASA, it's like, walking on the launch pad, it's an amazing feeling. And working with the people, it's even more amazing because everybody puts their passion, they're all highly involved in themselves. They're passionate about their work. They sacrifice quite a bit. So in my case, I think I was literally amazed to see this big rocket standing on the launch pad, and I was lucky. I felt that it was a great thing that I became a vibroacoustics engineer, because I could go and work on the launch pad. And then once you start getting involved with the vibroacoustics, I knew so much about. I told you earlier that we had 100,000 acronyms or whatever at Kennedy Space Center. You have to remember all that. What is MECO, and what is VAB, and what is CT, and what is MLP, and what is LCC, and many things. So all those things are very important. So more you put in your effort, more you become knowledgeable about that. So I think not until I met Pamela Melroy and started getting my Silver Snoopy Award because I did something, some testing on the space shuttle because they had a problem in the water coolant loop where the water coolant system takes the heat from the crew compartment and sheds it out. So NASA gives you the opportunity. So in my opinion, nobody ever told me to, okay, go and solve these problems. You are a vibroacoustician, but we are looking at solving complex problems, So one thing Thomas Friedman says that, in the 21st century, knowing all the answers is not important, asking the right questions. So what NASA is good is the NASA people are in collective thinking, I told you earlier, collaborative activities. We put our entire knowledge and education and experience together and the wisdom together. And that's how we come out ahead. So in my case, I started not only solving complex problems on the space shuttle, on the hypergol system on the launch pad, which is the monomethyl hydrazine nitrogen tetroxide, how it flows. I'm not a flow engineer. I'm a, structures engineer, but I tried my hand everywhere. We solved the problem working inside the payload compartment. I went inside the crew compartment 4 times. So NASA gives you opportunity to do all that. And then as a systems engineer, I would be on the launch pad designing issues, looking at big crawler, 1,000 kilo crawler transporter. How do you do a modal analysis of a structure like that? People would say, it's not possible. So I think the thing with some of the NASA engineers was that we believed that everything was possible. I think that's the major thrust. What I want to impress upon you is that the possibilities game we played. And that's why we came out ahead. When we had a goal to fix something, we didn't change the goal or goal post. We just came up with many alternative ways to get there. And I think that is the beauty about we innovated. So I want to talk a little bit about innovation because NASA is big in innovation. Again, when I say NASA, I'm talking about even contractors in NASA, maybe professors working outside, like researchers we talked about. So innovation is the ability to see things, and see opportunities others have missed, basically. I say the seeing the unseen, hearing the unheard, knowing the unknown, basically. So what do I mean by seeing the unseen? When Michelangelo was given a big block of marble, he said that's no good. It has cracks. Many people said it has cracks, but Michelangelo looked at the statue of David. So I've been to Italy to see the statue of David. It's beautiful. So he saw a statue of David. He didn't give up. That's called seeing the unseen. Hearing the unheard. I talk about 2 subjects. When you play the piano, you bang on the keyboards and you think that there's a gap in between. People don't play the music, and that gap itself is there's no noise, but that's also part of the music. So you can't just bang on the piano and create music. Beethoven always had gaps. So that's hearing the unheard. And a good example on the space shuttle is when the space shuttle rocket lifts off, everybody claps because they're looking at the high frequency sound coming and hitting their ears. I'm, as a vibroacoustics engineer, I know that until the low frequencies 0 to 20 hertz, which human ear cannot hear, come and hit my shirt 3 miles away at the speed of sound, 343 meters per second, it takes about 15 seconds for me to, the long frequencies from 1 hertz come and hit my shirt, and I become part of the shuttle, and then I know that this is beautiful, that we are successful. So this is what I talk about. You have to come up with innovation. Innovation is quintessential for success in whatever you do, and it's all about making connections, and that's what NASA is good in. We are very good in connecting things. We're good in analysis. And once we understand the root cause of the problem, we can answer many questions.
That was really insightful, sir. Um, Now we'll move. Some audience had some questions, so we will move on to them.
Sure.
Yeah, so this one was from Saransh Agrawal. He's second year EC. Is that with rapid reducing cost of human spaceflight, how soon do you see it becoming commercialized?
I think we are venturing on the commercial side, but I think people are still not ready to go fully. When I say people, I'm talking about Elon Musk and other companies, because see, one thing I was lucky compared to many people is that, you launch of rockets. We've been launching rockets since late 50s, and ISRO started in 62 and stuff like that. But we started launching manned rockets to moon. I mean, manned spaceflight is very, very tricky business. I tell people, I'm very adamant about that, saying, launching rockets is not like flipping burgers or flipping pizzas. You have to put your heart and mind and soul in that, because one tiny mistake, you make, it will cost, can you imagine each launch? I just want to impress you. The space shuttle itself is about $2 billion. The solid rocket boosters and the launch, everything combined is about 5 billion. I lose a launch pad, it's about 10 billion. So we are talking about, and what is the cost of human beings there? I don't know. Each launch cost me $500 million. So there's tremendous amount of, 1 day delay is about $1 million. So there's very, very important things we have to worry about. So I think Elon Musk won't commercialize because he may get very little money to send you or me to space, whereas NASA is giving him 60 million. So would you rather take 200,000 from somebody or take 60 million from somebody? I would take 60 million from somebody. So I think space tourism will happen maybe in 10, 15 years, 20 years, but not until then. Until we come up with more capacity for people to go in space, and that won't happen because launch costs are still high, in my opinion, and launch itself is a very dangerous business.
Truly insightful, sir. There's a question by Chinmay. Is that can you guide us about the fields in space technology in which the innovation and researches are being driven?
Can you repeat that question? I was just...
Sure. Can you guide us about the fields in space technology in which fields and researches are being driven?
Yeah. Well, basically, I think, still my feeling is that, NASA is working what they call as robotic refueling missions. So, everybody is putting satellites there. I mean, ISRO is putting satellites. Elon Musk is putting satellites. Everybody wants to put satellites there. But, sometimes these satellites will go bad. And now that satellites are cheap, quite cheap, we can still send more satellites. But then it becomes a big problem with space debris and other things, already we have enough things there in space. So I think robotic refueling missions for satellites will be very important. Not only refueling, but also repair missions. I think that's one area I want to focus on. And the other thing is asteroid mining. So I think even though individuals may not be able to do that, but you have to piggyback on ISRO or ESA or NASA, somebody to do the research, because whoever comes up with asteroid mining, like some of the asteroids have trillions and trillions of dollars of resources, and the Earth is dwindling its resources. We are getting out of resources because one day we'll be running out of important things which we need for making computers and many things we need. The other thing is obviously mankind has always been a traveler. We came from Africa 100,000 years ago. We did two things best: communication and transport ourselves. Now, as you know, more and more we are communicating tremendously. I just put a payload called Opals on ISS, and this Opals beams a laser beam, and we are dumping data from on lasers, on light, basically, large amount of data. So no more communications the old ways, So transportation is another thing. I think we have to journey to Mars. even we may not colonize Mars. I don't like the word colonize Mars. I want to say explore Mars. Nobody can colonize anybody. I think I don't think aliens are going to come and colonize Earth. So don't worry about it. Or whatever NASA or somebody says, don't worry about it. It's not going to happen. I think we are capable of taking care of it. So I think terraforming and other things, we do long duration experiments in space will help us. So to answer his question, I would say in my own lifetime, I've never thought in my in realistic imagination that I would be seeing people living and working in space 20 years. So as we embark on the ISS, I put Node 1. I put all the modules of the International Space Station in space from Kennedy Space Center, and we put them in space together. I mean, that's a tremendous feat. And now many experiments are being done on. I've sent small mice to alpha magnetic spectrometer, $5 billion, Japanese mice, fruit flies to space, IDA, the International Docking Adapter, many things to space. So all these things are very important. So working with ISS, I think you can come up with many areas of expertise. And I think we need to understand low Earth orbit before we go any further. That's my opinion.
Yeah, that was amazing. So there's another question by Pushkar. He's in third year, AC, Aerospace Engineering. Being the solar system ambassador for Jet Propulsion Laboratory, what steps are being taken up by NASA to dig up farther in solar system exploration? And what are the different types of advanced propulsion systems that NASA is working on?
I think I may have to. I can tell you right now that I'm not a big propulsion guy, so I'll defer that to JPL, and really that's not my field of expertise. But I think exploration, we have really in my own lifetime. When I first came to Kennedy Space Center in 1990, I launched Magellan to Venus. We launched, Cassini. We launched Galileo. We launched Ulysses to Sun. I think, and then already we were looking at Stardust. We had sent probes to collect stars from comets and other things. We are sending more and more probes to sort of kiss the sun, as we call it. And now we are exploring Mars, which is the nearest planet. So, as far as exploration goes, yes, there will be more and more robotic exploration from JPL and NASA. But I think more important for me is to focus our energies, because there's tremendous cost involved. Voyager 1, Voyager 2 were supposed to just go to Mars and a little bit beyond that, but they kept on going using the slingshot method. So now they are both almost 16-17 billion miles away from from Earth. So really, that is the basics of exploration mankind want. And I think we should put more more telescopes, like the James Webb Telescope going to Lagrange Point, and continuing with Hubble Space Telescope to explore the universe. So wherever possible, do it intelligently, not waste the money. Money is a resource, and we cannot just waste the resource. So it's important that we use it judiciously, both human resources as well as financial resources. It's very important that we, in America, we call it the bang for the buck, meaning for $1, what is the benefit? If one project gets you $10 benefit, and the other one gives you 100, go with the one with 100, obviously. So that's the way to go, I guess. So as far as, various different propulsions, I would want him to, I'm not expert in that, and I don't want to go into details. If you want some information, we can give it to him. But a lot of times, it comes under ITAR. So basically, we cannot tell some of the information, what JPL is doing. So whatever in the public domain you're willing, you're welcome to use, I guess. So only one thing I worked a little bit on is the ion propulsion engine. That's the one which we talk about for going to Mars. But it's using xenon ions, which is you expend out of a rocket nozzle at very high velocities, but the speed of the rocket itself is very slow there. So it's good for large masses if you want to take a whole fleet of things to Mars. But that's against the principle of NASA, I guess. When even if you see Apollo programs, the idea was to take Werner von Braun wanted to have a lunar Earth rendezvous. So he wanted the biggest rocket to go and land on Moon. But then this NASA engineer came and said, we will come up with a lunar orbit rendezvous. So we sent a small lightweight structure on the Moon, which could come back very easily. So I don't know. I mean, I'm not keeping up with a lot of those things right now because I'm trying to write my book and stuff like that, which I mentioned to you yesterday, writing my journey from RVCE to NASA and stuff like that. So I'm doing less and less travel now with COVID, Corona business also. So trying to stay away from that. So.
I hope Pushkar answered your questions answered. So there are a couple of more questions, so we go quick. This one is from Niranjan. He is in telecom department. If one wants to get into entrepreneurship in field of space, what are the major points that he or she needs to keep in mind? Do you think this is in space sector is riskier than any other field?
So can you repeat that again? I lost a few words there.
Yeah. So if one wants to get entrepreneurship in the field of space,
okay,
what are the major points that he or she needs to keep in mind? And following, do you think entrepreneurship in space sector is riskier than any other field?
Yeah, good question. So that brings me to third aspect of it, of my sort of notes you want to write down: self-esteem, taking risks, and fear. Those are the three main things. And I personally lost about maybe 10, 15, 20 years of my life, being afraid of doing things and being a shy and introvert kid and not taking risks. And even after coming to America, I didn't take risks to do many things, So risk is proportional to reward. So by taking risks, you may lose, but if you don't take risks, you'll be always a loser. So more importantly, there is always fear in what you're doing as an entrepreneur. But entrepreneur is the one who's going to, as Henry Petrorsky says, necessity is the mother of invention, basically. So, I mean, desire, not necessity, is the mother of invention. So necessity is the mother of invention, which everybody knows, but he says desire. So it's your desire, your passion, on what you want to do. So basically, you as an entrepreneur, you ride the waves, remember you throw a stone in the water and you make ripples. So a lot of times, take a look at what Steve Jobs did. He didn't invent anything, the internet was there already. The phone was there already, so everything, he put it in a nice package, basically. And that became one of the best iPhones selling in the world right now. It's a $2 trillion company now. So basically, yes, when it comes to space entrepreneurship, I think it's nothing. It's similar to what you do in any entrepreneurship. Every entrepreneurship has a problem or has issues and stuff like that. But you have to have the confidence. You have to have the self-esteem, And self-esteem is one of the most important things to be successful in life, The art of possible. So one example I want to give you is basically is the aspect of Werner von Braun. When John F. Kennedy said in '62 at Rice University, he said, we want to go to moon and do these things, not because they're easy, but because they're hard. And, really nobody, including Kennedy, didn't believe it. Only von Braun believed it. And he said that if there is one person in the whole world that I can land man on moon, and along with NASA, I can do this. Nobody else will do that because I have the ability and focus and stuff like that. So that self-esteem, I think I got when I got my Silver Snoopy award from NASA. And then you're branded as the best engineer in NASA. People, call you, respect you, and stuff like that. And that adds more respect and that gave me an impetus to work in becoming a international public speaker, take VIP tour guides like Dr. Kalam and many people in the world, and go around the world giving lectures and stuff like that at some of the best universities, including Cambridge and Oxford and all that. So self-esteem is important. So what he has to appreciate is he has to believe in himself, with this idea. He has to come up with a dream and believe that it can be done, and there's nobody else in the world he can do it. And I think he can find. I think going back to Petrovsky, best thing for him to do is find limitations. So in 500 years ago in London, there were 500 different types of hammers were sold. Why do they want to have 500 different type of hammers? So basically, hammer is really needed to hit a nail, but then they added a nail remover. Somebody like Abhishek said, okay, I don't want like Dr. Ravi's design, I'll put a nail remover. Then somebody said, I want to take this hammer and kill an animal or something like that. And then he extended the handle, or he made it from a different material. First, the hammers were made out of rocks. So he had to understand geology to make the best rock. So, see, what happens is basically innovation is a function of limitations of the prior design. So a good example would be one guy who had gone to a third world country, and he saw people carrying, he went to the country with the suitcases, and then the people came and picked up the suitcase, put it on their head, and walked to the bullock cart and whatever, or a horse cart, and put it in the cart. So then this guy, he's an American, I think, and he said, wow, this is interesting that they're carrying my suitcase and putting it in a cart. Now a cart has wheels. How come we don't have wheels on the suitcase? I can move it myself, Obviously, if you have 10 suitcases, you can move it in the airport. So, but he put wheels and he became a billionaire. So just by observing things. So two things are important here: introspection and observing things. So why Leonardo is Leonardo today? Why Michelangelo is Michelangelo today? Or Von Braun or Bill Gates or Steve Jobs is Steve Jobs, because they could see something out of the unseen, or knowing something out of the unknown, basically. And they could visualize that this is the limitation of the prior state of the art. So I would advise him to look at everything. He walks around, does things in the morning, looks at his work with a different set of eyes, Maybe I'll loan him the Hubble Space Telescope.
That's truly insightful, sir. This is from Anshul, Aerospace Department, that what can an aerospace student from India do to become an astronaut? Should one go for a master's degree in aerospace engineering from institute in India itself or abroad?
Good question. So really, if you want to become an astronaut, you have to have your head in the clouds, I guess, as they say. You can't be wandering around a city of Darjeeling and think that I'll end up on Mount Everest. So he has to really put all the things in perspective and put the steps in the process. And what is that, basically? So let's follow the steps of two people. I think he knows both of them. He knows Kalpana Chawla and he knows me. So basically, we were sort of two Indians out of a billion plus. We started our journey from India with no knowledge of NASA or anything like that. So as we went along, we got to America, and obviously she always wanted to fly in Colonel Flying Club, I guess, as they said. And then she had pictures of space shuttle there when she came to America. So as luck favors her, she came to Texas, and her roommate was one of the guys, British guys. He was a pilot, and so she started learning lessons for being a pilot. So in my case, I came 5 years before her. I came to America in 75. She came in 82. So I studied aerospace engineering, and I tried to aspire, just to put my goals a little bit, 5 miles, 10 miles above the earth. So putting your goals is very important, as we talked about earlier. So then next thing happened is she wanted to get her master's. So he should get a master's and get it from a university like University of Colorado, which had many, many astronaut candidates. So when she found out that many astronaut candidates are coming from there, like Georgia Tech or Embry-Riddle University in Daytona Beach, so he has to become a part of that team where most astronauts come from. And so after that, what she did was she said, okay, I want to be expert in scuba diving and do all the necessary things which NASA wants to make you an astronaut. So flying is one, scuba diving is one, extreme training where you're put up in remote places and survival training is very important. Those are the three main things. But then there's a very good video sequence by Chris Hadfield. He said, why should I take you to space with me? What qualities you bring, what traits you bring. So I think it's one of the movies I saw, 6 segments of videos I saw on Emirates Airlines coming to America. You should see that. But most importantly, she said, I want to have an expertise. So she went to work for NASA Ames. And right around 1988, she became part of NASA Ames. That's the same time I went to Kennedy Space Center. So we were at the same place. But my goal was just to be an engineer. But her ambitions were much higher. Her goals were much higher. So she moved her goal. She didn't move her goal post, but she kept on finding ways to get there, basically. And so she met a lot of NASA people there, worked in CFD. NASA Ames is historically good for computational fluid dynamics, and that's where she worked. And she had connections with the University of Colorado. There were astronaut candidates. So when you get selected for astronaut, you become an astronaut candidate. And then you go through the 2 years of training, and then you become an astronaut. You don't become an astronaut until you lift off from the launch pad. Not when you go to space. You have to go, when I ignite you on the launch pad, and you go 1 nanometer, 1 nanosecond above the launch pad, you become an astronaut. So I want to tell you a story about Dr. Kalam when he came to America. I was touring him, and I was telling him, I said, I'm just an ordinary ground systems engineer. And then he looked at me, and he was a little bit upset, I guess. He said, but he jokingly said, look, I was like you once upon a time at ISRO, okay? And he was calling the shots for launch. So basically he said that 50% of the mission success is just moving the rocket to the pad. The next 25%, you ignite the rocket and getting off the pad. So 75% of the mission success comes from you. The 25% is coming just from the astronauts who just sit there and do nothing, basically, just take a ride to space, So he said, don't say that you are not important. You are the most important person in NASA because you are the one who is making, you are the astronaut maker. You are the one who makes astronauts. And luckily, as a part of the NASA team, we made 700 astronauts, 100 launches. It is impossible for a person to get a chance to work on 100 rockets. Not only measuring rocket noise and vibration, working on the launch pad, and meeting somebody like Kalpana Chawla. I met her like 2 feet away the day she became an astronaut, and she became the first Indian woman in space. So, these situations don't happen. It was not planned, but that's why I think you have to take the risk and take the journey. And he can do that. I don't believe that he cannot do it. He has to just have a goal post and keep on coming up with alternative ways. Even if he fails, failure is not the end of it. It's a beginning of, a new journey, basically. It's not the end of one journey. So, and as Cabana says, from small beginnings come great things. So he has to have that passion. I just want to talk a little bit about JFK, one quote. So JFK came to Kennedy Space Center one time when we were launching Apollo rockets. And he said, he looked at a janitor. And the janitor, he said, what are you doing here, to the janitor. The janitor said, sir, you don't know what I'm doing? I'm launching rockets to the moon. I'm launching man to the moon. And that's the passion we are talking about. If you want to become an astronaut, you have to have that passion. Without passion, nothing happens. So it's like, cutting my hand and no, there is no blood coming out. I think only NASA is coming out. That's passion.
That is truly inspiring, sir. We have 8 more questions and we are out of time. We'll just take 2 questions. Other questions you can email Dr. Ravi. The first question is from Puneet, is about what are the thoughts on CubeSat missions paving way for future human spaceflight?
What are they?
What are the thoughts on CubeSat missions paving way for future human spaceflight?
I think communication, as we talked about, is very important. I think that's why Elon Musk is looking at now launching many satellites. ISRO is already launching many satellites. So in future, we need lot of satellites up there to communicate with what we are doing. It will help human space flight tremendously. And I think satellites are becoming smaller and smaller, which is good. Basically, then payload is always a penalty, as you know, in rocket launching. The shuttle weighed about 4.5 million pounds. We had to have 6.5 million pounds of thrust, which is 1 million kilo more. So for every 3 million kilo, I need a 1 million kilo more of thrust. So it's very important to know that the payload weight is critical. But there's a issue of human payloads and the issue of payloads like satellites. So you can have a problem with the satellites, but not have a problem with the human payloads. So human payloads, you have an order of magnitude. I would say maybe few orders of magnitude problems one has to face to launch people. And if you don't, you make a mistake, and you'll have a disaster like Columbia or Challenger. And I can guarantee you that SpaceX or anybody else embarking on maybe first 7-10 missions, they will have a big disaster, because that's a learning curve one has to go through. I don't want to think about it, but because you don't have done due diligence in terms of understanding the systems or systems engineering and solving all the problems you have. So just a good example, when Elon Musk started launching some rockets to space for ISS, we were a little bit concerned about from safety standpoint. And I was the ground safety chairman for all the ground objects going to space. And I was very concerned about one module called the IDA, International Docking Adapter. And on one of the launches, SpaceX launches, he blew the rocket up and we lost that. So it's bound to happen, but we shouldn't be afraid of that.
I hope that answers your question, Puneet. And we'll go to the last question of the webinar. This is by Adarsh Agrawal. Is that what are the aspects and intricacies related to aerospace engineering, masters in US in post-COVID era, keeping in mind the ITAR issue?
I see, Trump is going to go away one day, whether it's 3 months, 4 months, or 4 years, he will go away. So we'll make sure of that. I'm a Democrat, I guess. So this is my feel, okay? For Indians, I think it's a golden opportunity, See, this is a funny story. I think one of my friends from ISRO is on the webinar, and we were just talking the other day, and it's a funny story. So I said, he said, Dr. Ravi, I'm going to my village to see a girl. I said, great. I said, why do you want to go to your village to see a girl or his native place? I said, Bangalore has many girls to see and get, And he said, oh, Bangalore people, girls, all they want is IT people. So that was a funny story for me. But I think how IT capitalized America, you look at, Microsoft, you look at Google, you look at many chiefs of IT companies, all run by Indians, And then here comes Kalpana Chawla breaks the space ceiling. Then we have Kamala Harris breaking a bigger ceiling, really, here, So basically, I feel, that this is a golden opportunity for Indians. I mean, when I say Indians, I'm talking about aerospace students who really are passionate about coming to America, because America doesn't have much aerospace engineers. And as America wants to go more and more, we'll need more of those aerospace engineers. And this is a golden opportunity for them to come and study in America. And the path should be very simple, just like I did and Kalpana did. You just come here, get into a master's program in Embry-Riddle. Yeah, it may cost you money, but in the long run, look for the long haul, I came with few $1,000s in my pocket, with no green card and, no admission, no nothing basically, right? I took a chance, so, and look what happened right now, so why can't we take that chance? What do you have to lose? What did you bring when you came to this world? Nothing. We go back to Indian philosophy. I didn't bring anything. I don't take anything. All I leave is my legacy. So basically, it's important for you guys to think that, okay, let's do the impossible possible. It's how you read the impossible, I am possible. So come to America, get a good admission into University of Colorado. I'll write a recommendation letter for every Indian coming to America, okay? And my NASA recommendation will reflect definitely good, because I'm a gold standard in America. I'm a gold standard in NASA. So it will work, I know. So basically, once they come here, do the same thing. Learn how to fly, do scuba diving, understand how to survive in remote places like Alaska or Antarctica or wherever that may be, and follow the protocol. And, then, US companies like Elon Musk or Boeing or Lockheed, they will have to take you, just like they took me, And so, yes, there was a problem for me to get into Boeing, okay, because I didn't have a green card. But because Conrail gave me the green card, I could get in Boeing. So, and then I got the citizenship, which helped me to come to NASA. So that is the logical step for you. So you get a job with an aerospace company, they'll sponsor you for a green card. From there, you get a citizenship in 5 years, and then you apply for NASA. So if it takes 40 years, 50 years, and you're old, who cares? I mean, look at our senators, John Glenn and people like that. They were pretty old when they went to space. So if that's what you want to do, go after it. Don't give up hope. I just want to read a good quote because he talked from Robert Goddard. He says, "It is difficult to say what is impossible, for the dream of yesterday is the hope of today and the reality of tomorrow." Okay. So basically, in 1962, when Kalam and some of those people came to NASA to study sounding rockets, okay, they never thought. They started from a small beginning in that small church in Tumba, and look what happened. They were taking rockets on the back of a bicycle, I mean, it was a hilarious thing, I mean, it is as hilarious as when Varun Ram Brown said, let's find out the natural frequency of this Apollo Saturn V rocket. So we didn't know how to vibrate it. So we were pushing it with pulling it on one top and pushing it from the bottom with the rubber, tennis shoes. So there's a joke in NASA, it says, tennis shoes made NASA go to moon, So that's what it is. That's what it is. So I think Kalpana Chawla and we gave a impetus to you guys that some things are possible. It's like getting into NASA launchpad. It is impossible. Only if you are disguised as a alligator you can get in, because I have NASA is a zoo basically. 5,000 alligators. They go everywhere on the launch pad, on the landing platform. Landing facility. So to answer his question, I broke the barrier for entering NASA's launch pad and be the systems engineer on the ground systems. Yes, I have never become an astronaut. I never dreamed about it. So, I never achieved that goal. But Kalpana dreamed about it and she made it happen. So you have a precedence now, So you just follow the, I'm not saying you should follow our paths. You can come up with a better path. So if you have a better path, go after it. Maybe do it, in a shorter way. Because Kalpana came in 82 and she became an astronaut by 97.
An extremely insightful event. I would like to hand over the stage to Dr. RSK. To give the word of this.
Good morning, sir, and good evening to all the Indian, young friends of, RVCE. Sir, it's been an amazing webinar. I must say that it is very engaging right from the start. Sir, I think many, many thanks to you from, not just the Team Antariksh from RVCE and on my personal behalf for taking time off from your schedule and spending time with our students. I'm very happy that you took time off from your, you spent almost 2 hours tirelessly. You're going on and on. I think it's only Abhishek said that we'll put a stop. You never said that enough of, I think I really appreciate your energy. I really appreciate your, interest, and I really see, I'm hats off to you for your patience and involvement, sir. So I think I think it's been a very unusual webinar, because when the students approached me, there is a webinar they have planned. I thought it's going to be structured webinar the way normally most of the webinars are. I think this has been a very unusual webinar, and you have kept the students, glued to the screen and listening to you. And I think, I'm sure students have benefited a lot, sir. I think I request, let this not be the one-off, just a one-off, webinar. So let's say maybe at least maybe once in 3 months or maybe another 6 months. Even if you cannot travel to India, I request you to please spend some time with our students. As you saw from the interaction, there is a lot of interest among students. And also, although I head the aerospace department, I give all credit to the students. They are self-starters. Although I am the faculty advisor, just a namesake, probably I would say that we just don't stop in their whatever activities they plan. We just support them in their activities. And most of the work they do is they're all self-starters. They look for the information here and there. And I'm sure in just 5 years, they have done a huge, they have achieved so much. I think they just showed you a screenshot in which they talked about the kind of publications they come out with, and they have participated in the IAC. In fact, we attended the Team Antariksh had representation in the IAC 2019 also. In fact, I also traveled to US. I don't know whether you were there. I know. Did you attend that meeting, sir?
No.
IAC, we had about nearly 10 publications from Team Antariksh. RVCE has its presence felt at IAC 2019. So I think, sir, your talk, that too being an alumnus of RVCE, I'm sure students have benefited a lot. They can connect to you more because you have been their super senior, and your success story from RVCE to NASA. It was a really amazing, webinar where we got to know. I think probably you have shared so many. I think you tried to cover all the important milestones in your life and the problems you encountered and your inspirations. And I think it's been a very interesting webinar. You touched upon several things that I think probably, I don't know, a student would have done a better justice to this word of thanks. But I felt that I should, these are my, personal observations. And I wish I were a student like my the Antariksh teammates to be inspired by your talk. Even now at this age, I feel inspired that probably I think a few things probably what we are missing in India. Probably we are, although some things probably we are slowly trying to improve upon. I think when you compare the education in the US and education in India, somebody asked a question and you said, the many questions and, let's say one question and many answers, that is an amazing insight, because normally we have structured thinking that one question, one answer, and you said one question, many answers. Probably that said all actually. So I would say maybe I'm sure a lot of our students are aspiring to do their education in the US. I'm sure many of them will be looking at joining NASA also. But we want at least some of them to come back and join ISR also, because we want the Indian space program also to be strengthened. So I think it's been a guiding a webinar. I'm sure a lot of students are inspired and to take this journey. And so a lot of things we touched upon. So I wish I could make a notes. I think probably I'm happy that Abhishek has made a recording of this, and with your permission, would like to share with others who couldn't attend this webinar. And the root cause, your journey, the professional journey, and your your journey in Boeing, and then how you moved on to NASA, and your association with Kalpana Chawla, and the mantras you just mentioned about believe in yourself, chasing your dream. And I think it's something which is probably I don't have time to touch upon. I think it may be, I don't know whether I'll be able to justice to the entire list here. But I think you touch the entire gamut, actually, including probably giving examples of the present day innovators like Elon Musk and Steve Jobs, and probably you have covered everything, sir. So hats off to you, and also your focus on how we should develop the practical knowledge, which probably in India, as you said, probably we are picking up, sir. Actually, I must tell you something about what this Antariksh team is doing. So we have given them the free hand, and they do a lot of testing, and things have changed. Things have changed, and they try to learn on their own. They do their own small experiments. Some experiments leading to even like firing of small rockets also. When we are doing some studies, we were wondering what it leads to, small explosions or whatever. And then I have taken some risk and given them the permission with some remote corner of the campus. They do some experiments. We'll show you also where they do some experiments. And so I say this generation has changed. I think probably the RV of those years when you were in RV and this RV is different, because I've been in RV for almost 3 decades now, and I'm seeing that the last 5 to 10 years there have been a lot of changes, and at least Team Antariksh is really we have very, very bright students committed to learn more about space engineering, and I think people like you should guide them. So I request you, sir, please stay connected to the team, and I want you to share your expertise, and I'm sure some of them may even write to you, mail you, and probably I request you to see during your free time, whenever you could take some time off. So maybe you could address those questions and guide our students. So my profuse thanks. Yes, sir.
Most definitely, I guess I just want to say 1 or 2 things. We talk in NASA. This a lot of times we use opportunities like this to tell a story. And I just want to impress upon the audience in the last few minutes is that the story about a woodpecker. One time a mommy woodpecker and a daddy woodpecker, they wanted to have babies together. So basically, this is a true story, by the by. So I had the space shuttle on the launch pad, the orange tank looking beautifully, and everything was assembled together. And now the mommy woodpecker, we just make the story a little bit funny, told the daddy woodpecker, hey, go and look for a nice tree for me. We'll have your babies, So she sends the daddy woodpecker, goes around the launch campus, and there's no trees right around the launch pad because of the fire hazard. So it goes and looks at the orange tank and says, wow, this is beautiful. My wife will like the orange tree, So he pecks like 300 holes in the tank, And the orange tank is made out of aluminum, and it has foam on top of it, about 5-inch thick foam. So we were worried about, and then they came to me about launching the rocket with that problems. And I said, no way, we have to bring the rocket back to the VAB. And in the meanwhile, NASA is sending all these emails around the world trying to see how do we get rid of these woodpeckers, because there are birds hovering around all over, making more holes. And so we started, so every day delay was costing me $1 million. So I had to bring the rocket all the way back to the VAB because small foam hit Columbia and created a big problem, as you know. So we didn't want to take a chance. So anyway, as we were repairing it and refurbishing it, we had to take it back to the pad. 30-day delays, $30 million. So as it happened, a lot of people around the world came up with the answer, well, why don't you take a gun and shoot the birds? NASA is an environmentally controlled, animal-friendly place that we can shoot birds, and in the process you may shoot the rocket. So that was a stupid idea, but somebody came up with that anyway. And then as we went along, the next idea was, oh, why don't we find a predator for the woodpecker? And everybody found out owls. Owls are predator for woodpecker. The only problem is, again, environmentalists would be mad at us to capture a owl and train him to go after this woodpecker. So that was a no-no, basically. And, I was laughing at everybody because in India, my mother always would say, don't bring an owl home. It is a bad omen, And here, we are trying to send an owl after the woodpecker. Anyway, finally, one NASA engineer came up with a brilliant idea. I said, why don't we take these balloons and fill them with helium? And we have a 100-meter launch pad, and we'll put every 10 meters, we'll put a balloon and with an owl face on top of the balloon. So fill up with helium and put owl face. And guess what? The birds ran away, the woodpeckers ran away. They never came back. And they still have a girl or guy sitting on top of the launch pad about 100 meters high and honking at them like a honk, This is the highest technology in the world, and we are still doing it the old-fashioned way. But going back to Leonardo, simplicity is the ultimate sophistication. So basically, many complex solutions have, complex problems have simple solutions. So that's a story I want you to take with you, because they may forget what all I said for the last 2 hours, but they will never forget the woodpecker story, which cost us like dearly $30 million and 30-day delay. But one thing I want to, self-esteem has been very important for me. And I want to instill that among all your students. And for that, public speaking is very important. And I've been to 40, 50 countries around the world, never been to TED calls, TED talks or whatever. Not because they didn't want me or whatever. I don't know why they haven't called me, but I said TED talks is something fundamentally wrong with it, because it takes 20 minutes and nobody has that kind of focus, basic attention span. So I proposed a max Q talks, which is a 3-minute talk talking to astronauts and all that. So astronauts are trained to talk, stand up, we'll make Kalpana Chawla stand up on the podium and say, okay, talk about Russia, or talk about India, or talk about Ganesh Puja or something like that. This is how we are trained. And I want, when you crunch time and increase the space, so in TED Talks, they give you 20 minutes, but the space is limited. You have only so many audience, and only you are invited to that place, or you are invited to talk. Here you can do it in your house. Look at a mirror and do it. Stand there and talk about 10 different topics. So not only it encompasses or enhances your multidisciplinary capabilities, but also gives you ability to propose ideas. So even if you have a brilliant idea in Wall Street or even in California, you cannot come up with a venture capitalist and talk to him for 2 hours. He says, give me 3-minute presentation, and that's it. So max Q talks is one of the most important things. And last but not least, I want you to your kids to read the book or maybe see the movie October Sky, which is one of the engineers from NASA who followed my our journeys are similar, except his father worked in the mines and he stole railroad material to make rockets, and as a science project, and then became a NASA engineer later on. In my case, I came up from India and did something different, worked in railroads and mining and helicopters and all that. So, but I think the success we are seeing in your case and RV College, it's really amazing that I've met many students in America, and everybody says RV College is #1. And I said, wow, this is great. I never thought that we would be #1, and we did get 4 ranks at the university in 9th semester, and we didn't beat UVC, but always I wanted to beat it. And I think I got the 2nd rank at the university. We have got 4 ranks. And so it's important that, we aspire to have our own space race, in my opinion, So all the students, my humble request is basically, definitely we'll talk more, maybe, 3-4 months down the road. I have my book coming. It will be documenting my success and failures and my journey. and many places I've went around the world, which will help you, because as a tour guide, and for NASA, I met many people, including I was the tour guide for Ashutosh Gawarikar for Swadesh movie, also Abdul Kalam, the Indian ambassador. And then I've traveled many countries, and it's important to bring that perspective. I want your people to go around the world, give lectures, give presentations, and make themselves write papers and make them the best in the world. Thank you.
Thank you so much, sir. Thank you so much. I think guys are listening, and I think we look forward to your book, sir. Sir, we look forward to your book. I think it will be a pleasure to read your book and get more information, or in-depth information,
okay,
on your life experiences. And I think probably, sir, I think I really appreciated your dedicating the seminar to your parents, sir. Amazing. I really appreciate. I think a lot of young guys probably, that's one part I think our education system should, how we, respect our parents. And, I think I really appreciate that gesture that you dedicated this talk to both of your parents. I think
you brought up one more thing I want to mention, which I didn't mention in the lecture, is that I want to give credit to 4 women in my life, maybe 5. My wife, my mother, who really, was instrumental in getting me to RV College. My aunt in Chicago, she got me to Chicago to study aerospace engineering. My wife of almost 40 years, we've been together, and she was really helping out in many of my adventures. And last but not least, Pamela Melroy, my astronaut friend, and now my daughter Nina. A few women in my life who have really shaped me and made me what I'm today. So
thanks for sharing this personal information with us. Thank you so much. Thank you so much, sir. I think probably I could go on, and I think let's come to almost nearing 9 o'clock now. So my thanks are also due to once again thank Dr. Ravi for sharing your valuable time and connecting with our students. Hats off to you for your involvement, and my grateful thanks to you, sir. And thanks also to Mr. Srinivasan Margasahayam joining us in this webinar. I really appreciate that.
He's my competition, He's my cousin.
Oh, okay. No, yeah, but I really appreciate that.
So
yeah, okay.
We have a competition between NASA and ISRO all the time.
Oh, he's based in India, right? Yes, sir.
Yeah, okay. He's based in India. Yeah.
Okay. So my
he's
thanks
a big,
are also
big shot in ISRO. So if you want a job, go to him. If I want a job in ISRO, I come to him.
My Srinivasan, sir, wants to say something?
Sir, I want to just say something.
Yeah, okay.
We do this world specific. Earlier, we are doing in a very low key. And last year, we thought instead of students coming to ISRO, we'll go to the college. And RV College was the first college we did our...
I think you had come, sir. I think, yeah, I remember.
Yes, sir. Last year. And our controller... she also came. She also is alumni of RV College.
Yes. I think that's Bidri. Vijayalakshmi Bidri.
Vijayalakshmi Bidri. Yeah, she also.
Yeah, she came to inaugurate that. Right, I remember.
Yeah. Actually, we wanted to go full year. We wanted to do because of this COVID. We were unable to.
Yeah, I know.
We had a very good thing at RV College, and Ravi has been a very inspirational teacher. In fact, he didn't mention about. What happened at the height of COVID? He was stuck in Turkey. He had a tough time to get back to US. So not many people know about it. So somehow last flight which arrived at America, they managed to get out of Turkey and land in US safely. And that was a somewhat scary time at the time.
I understand.
Thanks, Ravi. It was very, very encouraging to students. I've been listening last 2 hours. I can go on and on for several hours.
Yeah. I can go on for 3 days.
Every time he comes to India, I make it a point to take him to ISRO. And whatever anecdotes he tells, nothing like sharing experience, personal experience, and sharing anecdotes and pictures and video. They all carry weight. That will remain in the minds of people. Yeah, it was really good. And ISRO also... We also have IST. Okay, some other time we'll talk about it. Now today is the release day. Yeah. Okay. Thanks for hosting it. Yeah. Thank you.
Sure.
Okay,
Thank
good
you,
luck
sir.
and
Thank you.
Godspeed. Yeah, bye.
So thanks to Abhishek and Kriti, right, who
Kriti.
anchored the program, and thanks to all those who participated actively and attended this program. My thanks to one and all.